Hey everyone, welcome back to Sajguru's talk. Today we are going to discussing about the assignment 3 from the Computer Networks and Internet Protocol MCQ. So let's get started. Totally we'll be having the 10 different type of questions. In that, the first one, what kind of sequence number does TCP uses? Options: byte-oriented sequence number, packet-oriented sequence number, randomly generated fixed sequence numbers, none of them. Generally, the TCP uses byte-oriented sequence numbering to ensure reliable, ordered, and efficient data transmission over a network. So, the answer is A, byte-oriented sequence number. Second one, identify the false statement in the following. So we need to identify the false one. The transport layer functionalities operate at an abstract level using data structures, algorithms, and system calls implemented in the OS kernel. So which is correct one only. The second one is the operating system kernel does not play any role in supporting the transport layer functionalities of the TCP/IP protocol stack. So options are given. So we know that the transport layer relies on data structures and to manage the connections, algorithms like what sliding window for flow control, checksum for error detections, etc. And to ensure reliable communications and system calls to interact with OS kernel, which implements these functionalities abstractly for the application use. So, but in these two different type of statement, we need to identify the false one. The option statement 2 is a false one. Third one. So, which of the following services is not supported by the transport layer? So, the transport layer provide services like end-to-end packet delivery, ordered packet delivery, reliable data delivery, connection establishment, and flow and congestion control, etc. Okay, so the three options are correct, A, B, C. The fourth one is the hop-to-hop network packet forwarding is supported by which layer? Data link layer and network layer. So the option D is not supported by transport layer. Fourth one. So what can be a primary mechanism used to ensure the reliable data transfer in a stop and wait algorithm? So here they are given the noisy channel. The options are given. Generally, the stop and wait noisy channel flow control algorithm uses a sequence number to individually identify each frame and corresponding acknowledgements. It ensures reliability by attaching a sequence number to each packet and transmits packet and waits for an acknowledgement from the receiver before sending the next packet. If the acknowledgement is not received within the time period, then sender retransmit the packet. So here the suitable answer is C. Using a sequence number to identify each packet uniquely and waiting for an acknowledgement for each packet before sending the next one. So this is generally the functionality of the noisy channel. The next fifth one is given some numerical problem. So they are mentioned the data of 40 bytes need to be delivered using TCP protocol, but a sender can send segment of maximum size 12 bytes only. Identify the sequence number of the last segment formed if the sequence number field uses 5 bits only. Okay, so the options are A 1, B 4, C 12, D 31. So generally, the TCP uses a byte sequencing. We know that it treats data as a continuous stream of bytes rather than discrete packets. Since the sequence number fields uses 5 bits only, it produces the ranging from 0 to 31. Why? Because the sequence number field uses 5 bits. 2 to the power of 5 is what? 32 bits. So the first segment of 12 bytes will use the sequence number ranges from 0 to 11 as the question in the question itself they mentioned. The next segment of 12 bytes will use the sequence number next continuous sequencing, right? 0 to 11 after 12 to 23. Next segment of 12 bytes will use the sequence number ranges from 24 to 31 and 0 to 3. And the last segment of 4 bytes will use the sequence number ranges from 4 to 7. So The sequence number in TCP segment headers refers to the first byte of the data in that segment relative to the start of the stream. So the answer is 4. Next, sixth one. A sender uses a sliding window protocol with a window size of 5. The range of sequence numbers follows modulo 8. If the receiver acknowledges packet 1, what will be the sender's new window range? So the options are given. When the receiver acknowledges the packet, resulting in a forward slide of a sender's window, the sliding window now starts at 2 till the allowed window size. So 2 to allowed window size. So 2 to 6. The answer is seventh one. Determine whether the following information is true or false. During the three-way handshaking of connection establishment procedure, delayed duplicate SYN synchronize can handled by TCP at host 2 simply by ignoring it, as the sequence number is invalid. We need to choose whether the statement is true or false. Now, the TCP three-way handshaking is a fundamental process that establishes a reliable connection between two devices over a TCP IP network. During the handshake, the client and server exchange initial sequence numbers. It uses sequence numbers to identify and validate the legitimacy of connection request. A delayed duplicate SYN synchronize will have an outdated sequence number that does not match the correct connection state at host 2 and can be ignored as invalid sequence number. So the given statement is true only. During the three-way handshaking of connection establishment procedure, delayed duplicate SYN can be handled by TCP at host 2 simply by ignoring it as the sequence number is invalid. So the answer is A. Eighth one. So TCP instance uses a sliding window protocol in the noisy channel. A timed out occurs due to the loss of segment on the acknowledgement. Mark the right statement among the following. Okay, so they are given A, B, C, D options. Now, in the case of go back N ARQ, if any segment of the sliding window is lost, all the segments of the corresponding sliding windows are retransmitted, while in selective repeat ARQ, only the lost packets are selectively transmitted. So the right statement here is, in the case of go back and ARQ, if any segment of the sliding window is lost, all the segments of the sliding window are retransmitted, while in selective repeated ARQ, only the lost packets are selectively transmitted. So the other three are false statements. Ninth one. So here they are given a numeric one. Identify the range of packets that will be retransmitted by the sender after the timed out packet. So in the go back NARQ, when timed out occurs, the sender retransmits all packets as we discussed just now, starting from the lost packets to all permissible packets in accordance with the window size. So the answer is 3, 4 and 5, 6. Why? Because the packet is lost at packet 3. So it will retransmit from 3, 4, 5, 6 and 7. Answer is C. Now the last one. A client and server establish a connection using TCP's three-way handshake. The following details are given. So they are given some details initially. The sequence number of the client, then round trip time, and each TCP segment carries 40 bytes of header information. And the server sends synchronize and acknowledgement segment and so on. Okay. So they were asking to how much time does it take to establish the connection under such a scenario? Since it is a simple formula only. So synchronized packet, we need to calculate the time for the synchronized packet plus time taken for synchronization plus acknowledgement packet plus time taken for the acknowledgement packet. So here they are given the round trip. We know that 80 is the round trip, but we need to take the half of the 80. plus 80 by 2 plus the given 100 milliseconds. The total is 180 milliseconds. So the answer is C. That's it for today's topic. So let's discuss some more content in the next coming video. Thank you for watching.